Okay, so in this video, we are going to be looking at solving quadratic equations by taking the square root, completing the square, and the quadratic formula. In part 6, we looked at solving quadratic equations by factoring, and that should have felt pretty familiar since we've been doing the x method and factoring for a couple of videos now. In this next video, or in this current video, I guess, we will be looking at 3 new methods that we have not been using. The first one being taking the square root. So the first thing we want to do is to get the perfect square by itself. Then we will take the square root of both sides, and when you square root both sides, you'll need to put a plus or minus sign, and then we're going to solve. So the first example, we have x squared minus 10 equals 6. So this is a perfect example of a problem where we want to use taking the square root. When we were doing this problem in the last video, I typically would have subtracted 6 and then used a difference of squares, and that's perfectly fine. What we can also do, though, is we can add 10 to both sides, and then I have, excuse me, x squared equals 16. And then I can take the square root of both sides, and this is where the plus or minus sign comes in handy, plus or minus the square root of 16. The reason why we do that, and we'll show here in just a second, we get x is equal to positive and negative 4. The square root of 16 is 4. And what we're saying here is we have x squared is equal to 16, and the x values that would give us 16 would be positive 4, 4 squared is 16, and negative 4 squared is also 16. And so that's why we put that plus or minus sign there. So we get x is equal to plus or minus 4, and you could write x equals 4 and x equals negative 4, or you could use the plus or minus sign. Now the next one, we have x minus 2 squared, and that's the piece that we're going to want to get by itself. So the first thing I want to do is go ahead and subtract 12. So I get 12 onto the other side, and then I have 3 times x minus 2 squared equals negative 12. And then I want to get that 3 off of there, so I'm going to divide both sides by 3. And then I have x minus 2 squared is equal to negative 4. And now I can go ahead and square root both sides. And what's nice about the methods that we're learning in this video is that it allows us to now solve things that before we couldn't. So before, this problem would not be something that we could solve. And the reason why is because we're going to get imaginary numbers. And factoring does not allow us to use imaginary numbers. It only works with real numbers. So now square rooting these cancel out, and I have x minus 2 is equal to plus or minus. And with that negative inside there, like we talked about in a previous video when we were working with complex numbers, this will simplify to 2i. So now I have plus or minus 2i. The only thing I have left to get x by itself is to add 2. Now 2 is a real number, and then 2i is an imaginary number, so those cannot be combined. So I have 2 plus or minus 2i, and that is my answer. So again, these methods we're learning in this section allow us to solve equations that previously we couldn't. Another example, we can go ahead and add 24. Again, we're trying to get this x plus 1 squared by itself. So adding 24 to both sides. We have 2x minus 1 squared equals 24. We can go ahead and divide by 2 on both sides. And I have x minus 1 squared equals 12. Square rooting both sides with that plus or minus sign. And I have x minus 1 is equal to plus or minus. And remember, the square root of 12 is the same thing as 3 times 2 times 2. We can pull a 2 out and have 2 root 3. And if you can simplify it, you need to. So I have plus or minus 2 root 3. I can go ahead and add 1. And that 1 cannot be combined with this. This has a square root on it. This does not. So x is going to be equal to 1 plus or minus 2 root 3. Going on to our next example, it looks harder, but it's really not. It has fractions in it, but that does not make this problem more difficult than the previous one. In fact, this one has less steps because there's nothing subtracted. There's no coefficient out front. I already have this piece here that's squared by itself, so I can just jump straight into square rooting both sides and putting that plus or minus sign out front. and that cancels these out, and I have r plus 2/3 is equal to plus or minus. And the square root of 1/9, well, the square root of 1 is 1, and the square root of 9 is 3. So that's just plus or minus 1/3. And the last step to getting r by itself is to subtract 2/3 from both sides. So I have r is equal to negative 2/3 plus or minus 1/3. Now, this is a real number. This is a real number. There's no square roots or anything, so I can actually combine these. I have r is equal to negative 2/3 plus 1/3, and I have r is equal to negative 2/3 minus 1/3. That's the plus or minus here. So negative 2/3 plus 1/3 gives me negative 1/3. Negative 2/3 minus 1/3 gives me negative 3/3, which is negative 1. So r is equal to negative 1/3, and r is equal to negative 1. On to the next page here. We're going to be looking at solving quadratic equations using completing the square. Now, I'm going to go through an example of completing the square first, and then we're going to kind of go backwards where we're going to be looking through the steps a little bit slower, and then we'll do some more examples. So the process of completing the square. We first off want to get the constant onto the other side. So it's a little bit different in our setup. We want the x squared term and the x term on one side, and then the constant on the other. So that's going to be my first step here. And what we're going to be doing is we're going to be adding something to both sides to make this side a perfect square. So essentially what completing the square does is it gets it in the form for us to use the square root method. Now, in this box here, what we're going to be doing is putting our b value divided by 2 and then squared. So my b value is negative 6. And the other thing is we want our a value to be 1. So if your a value is not 1, then we have to divide the whole equation by that coefficient. So in this case, and that's what's going to be going into both boxes here, because whatever we do to one side, we have to do the same thing to the other. So my b value here is negative 6. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm adding 9 to both sides. Now from there, this polynomial here is a perfect square. It can be rewritten as the same factor squared, and what that's going to be is x minus, and then what's going to go in this spot right here is going to be our b value divided by 2, not squared. So it keeps the same sign as what was here. So same sign here and here. And that negative 6 divided by 2 is just negative 3. And then on this side, I have 15 plus 9, which is 24. And now this is set up for the square root method. So let's just real quick off to the side here show x squared minus 6x plus 9. If I were to do the x method, 1 times 9 is 9. My b value is negative 6, negative 3, and negative 3. So that's x minus 3, which can be rewritten as x minus 3 squared. So we can rewrite it this way. It's the same thing. You don't need to do this work of factoring. That's what completing the square does, is we know that it turns it into from this to x minus our b value, and then that whole thing squared. So at this point, we're ready to go ahead and square root both sides, put our plus or minus sign in front there, and we have x minus 3 is equal to plus or minus, and the square root of 24, well, 24 is 3 times 2 times 2 times 2. I can pull out 1, 2, and I'm left with 6 inside. So plus or minus 2 square root 6. And from there, the last step to getting x by itself would be to add 3. Again, 3 cannot be combined with this because this has a square root on it, so it'll be 3 plus or minus 2 root 6. Okay. So that's the whole process of completing the square. These are the steps that we just talked through. I won't talk through them again because we just talked through them and you can just have them written there for you. In these next examples, all we're going to be doing is figuring out what would make that a perfect square. So this is just finding that b value divided by 2 squared. So here my b value is -8. -8 divided by 2 is -4. -4 squared is 16. Here I have 24. 24 divided by 2 is 12. 12 squared is 144. So that's that first example there. The next example here is just asking us to go ahead and solve by using completing the square. So here I have x squared plus 4x plus 5. First thing I want to do is get 5 onto the other side. I know I'm going to be adding something to both sides. So -5 plus that same something. And here it's my b value divided by 2 squared going in that box. So b is 4 divided by 2 is 2. Squared is 4. And then I can go ahead and rewrite that as x and then my b value divided by 2. So +4 divided by 2 is +2. And then -5 plus 4 is -1. Square rooting both sides and putting that plus or minus sign in front. We know the square root of -1 is I. So this is x plus 2 is equal to plus or minus I. From here, all I need to do is get x by itself by subtracting 2. That's a real number. This is imaginary. It can't get combined. So I have x is equal to -2 plus or minus I. So completing the square allows us to also solve things with imaginary solutions. Now the next one is nice because the 2 is already on the other side, but this number does not divide evenly. It's going to give us a fraction in our problem. It's actually not going to work out too bad. It won't be too complicated for us to have a fraction. So I have r squared minus 5r plus something equals 2 plus that same something. And -5 divided by 2 is, well, I'll just kind of do this off to the side here for you, 5 over 2. And then squared gives us 25 over 4. So 25 over 4, 25 over 4. Then writing it into factored form, I have r minus 5 over 2, my b value divided by 2, squared equals 2 plus 25 over 4. Well, if I want to add plus 2, I can make a common denominator there by multiplying by 4 over 4. And that would be 8 over 4. Again, 8 over 4 is the same thing as 2. So 25 plus 8 is 33 over 4. So that's what's on this right-hand side here, 33 over 4. And we're going to go ahead and square root both sides, put that plus or minus sign out front. And I have r minus 5 over 2 equals square root of 33, we don't know, but we do know the square root of 4, and I can go ahead and change that into a 2. So plus or minus the square root of 33 over 2. The last step to getting r by itself would be to add 5 over 2. So r is equal to 5 over 2 plus or minus the square root of 33 over 2. So not too much harder with fractions. Again, notice that all of the examples we're doing our a value is 1. If we did not have an a value of 1, we would need to divide the whole equation by whatever that value is. So if this was like a 3 in front, we would need to divide the whole equation by 3 before we could get started. Here I have u squared minus 10 plus 25 equals 0. Go ahead and get that 25 on the other side. We're going to be adding something to both sides. And my b value is -10. -10 divided by 2 is -5. -5 squared is 25. And hopefully you're noticing something here. We're going to have -25 plus 25. Those are going to cancel out. And over here we have the same thing we started with, but I can go ahead and write that as u squared, u minus 5 squared equals 0. Well, square rooting both sides, even if I put that plus or minus sign there, the plus or minus of 0 is still just 0. So I have u minus 5 equals 0. So adding 5, u equals 5. That means there's only one solution in this case. This is actually one we could have used the x method on. Okay. All right, one more example, and then we're going to move on to the quadratic formula. Here, I have the constant on this side, but I need to get the x's back over here. So x squared minus 2x plus something equals negative 17 plus something. And my b value is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. Then I have x minus and b divided by 2 is negative 1 squared equals negative 17 plus 1 is negative 16. Square rooting both sides, plus or minus. I have x minus 1 is equal to plus or minus. And with that negative in there, we know we're going to have an I, and the square root of 16 is 4, so 4i. Lastly, to get x by itself, adding 1. 1 is a real number, and 4i is not, so they cannot be combined, and that would be my answer. Now, the third method we're going to be looking at for solving quadratic equations is the quadratic formula. And you can look up all kinds of ways to memorize this formula, but bottom line is you do need to memorize it. You need to know the quadratic formula and be able to use it. And so make sure that you know it. There are lots of teachers who are braver than I with songs on YouTube, most of them to Pop Goes the Weasel, and singing the quadratic formula song. You can look those up. But make sure you have it memorized one way or another, however you can get that memorized. So with the quadratic formula, we are going to be rewriting our formulas back set equal to 0, unlike the completing the square method, and finding our a, b, and c value and just plugging them into this formula, and that gives us our answer. So of all of the methods we've looked at, I think this method is the one that takes the least amount of thought. All you really need to do is get it set equal to 0, plug in your a, b, and c values, and simplify. So there's not a lot of critical thinking or problem solving. It's really just plugging in numbers and simplifying. So first thing I need to do in this first example is get it set equal to 0. 2x squared plus 5x plus 3 equals 0. And the other nice thing about the quadratic formula is you can solve any quadratic equation this way. Imaginary solutions, complex solutions, any kind of quadratic formula or quadratic equation, you can solve using the quadratic formula and it'll work. Unlike factoring where not all of them are factorable, or completing the square where you have to have an a value of 1, or the square root method where you need to have it written as a perfect square. There's really no requirements here other than getting it into standard form and plugging in your values and then simplifying. So my a value here is 2, my b value is 5, and my c value is 3. X is equal to negative b, so negative 5 plus or minus the square root of b squared, so 5 squared is 25, minus 4 times a times c. And then over 2 times my a value. So I recommend writing it all out exactly like that, making sure you show your work. Because one, if I can see you've plugged everything in correctly on a quiz or an exam, but maybe you make a calculation mistake, I can still give you most of the points because I can see you knew what you were doing. You just made a simplifying error. But if I don't see any work, if I don't see you plugging in the numbers correctly to the right spots, it's really hard to give any partial credit because it's really just plugging in numbers. So in these types of problems, you want to give an exact answer, not just typing it into a calculator. Here we have negative 5 plus or minus, and then here we have 4 times 2 is 8. 8 times 3 is 24. So 25 minus 24 is 1. Negative 5 plus or minus the square root of 1 over, and then the bottom will be 4. Well, the square root of 1 is 1, so what we have here is negative 5 plus or minus 1 over 4. Negative 5 plus 1 is negative 4. Negative 4 divided by 4 is negative 1. And negative 5 minus 1 is negative 6. Negative 6 over 4 is negative 3 over 2 once it's reduced. So those are my two answers. Next example is already set equal to 0. My a value is 2. My b value is negative 1. And my c value is 5. Make sure you include the signs when you're writing out what a, b, and c are. x is equal to negative b. So negative times negative 1 is going to be a positive 1, plus or minus. Negative 1 squared is 1 minus 4 times a times c, all over 2 times a. Simplifying that, 1 plus or minus the square root of 4 times 2 is 8. 8 times 5 is 40. 1 minus 40 is negative 39 over 4. And we don't know the square root of 39. There's nothing I can pull out or simplify there, but I do know that the negative means I need to pull out an I. So 1 plus or minus I square root 39 over 4. And to get full credit on a question like this, you would need to pull out the I. If you left it like this, you wouldn't get full credit. So make sure that if you have a negative inside there that you do pull out the I. The next example, we need to go ahead and set equal to 0. So I have x squared minus 2x plus 10 equals 0. My a is 1, my b is negative 2, and my c is 10. Plugging into the quadratic formula, we have my b value is negative 2, so negative b would be 2 plus or minus the square root of negative 2 squared is 4 minus 4ac all over 2a. 2 plus or minus the square root of, and what we have here, 4 times 10 is 40. 4 minus 40 is negative 36 over 2. Well, that negative means I'm going to have an I, and the square root of 36 is 6. So 2 plus or minus 6i over 2. I can reduce that fraction there, and they have to reduce with all three here. So that becomes 2 over 2 is 1 plus or minus 6i over 2 is 3i. Now the next one has a little bit of an extra step here. I need to multiply this out before I can get this into standard form. You can use the box method or you can use FOIL. I'm not going to show my work for this one. I'm going to go ahead and just write out what that is multiplied. That would be x times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x, and then plus 6. Simplifying that, we get 2x squared equals x squared minus 5x plus 6. And then getting everything onto one side, subtracting x squared from both sides, we have x squared plus 5x minus 6 equals 0. And we can go ahead and solve here. So this is actually one that I know we could use the x method for and it would work out, but we're practicing the quadratic formula, so that's what we're going to use. A is 1, B is 5, C is negative 6. X is equal to negative 5 plus or minus the square root of 25 minus 4 times 1 times negative 6, all over 2 times 1. Negative 5 plus or minus, and here we have 4 times negative 6 here. A negative times a negative is going to become a positive. 24 plus 25 is 49 over 2. Well, we know 49 is, or the square root of 49 is 7, so what I have here is negative 5 plus or minus 7 over 2. Negative 5 plus 7 is 2. 2 divided by 2 is 1. Negative 5 minus 7 is negative 12. Negative 12 divided by 2 is negative 6. So with these kinds of problems, we can get real solutions, we can get something with an imaginary solution, we can get something with a square root, so many different possibilities. Another one here, we need to get into standard form. We have 4x squared minus 4x plus 1 equals 0. A is 4, B is negative 4, and C is 1. So x is equal to negative times negative 4 will be positive 4 plus or minus the square root of negative 4 squared is 16 plus, oops, not plus or minus, minus 4 times a times c over 2a. Well, 4 times 4 is 16. 16 minus 16 is 0, and the square root of 0 is 0. So what I have here is 4 plus or minus 0 over 2 times 4 is 8. Well, 4 plus 0 or 4 minus 0 is still just 4 over 8, which reduces to 1/2. And that means we only have one solution. And it is possible to get just one solution. On to the next page, and we're going to talk about one more topic. This is called the discriminant here, and then we'll go ahead and end this video after that. The discriminant is part of the quadratic formula. It's the part underneath the square root. And what that does is it tells us how many solutions we have. It does not tell me what the solutions are. It only tells me how many I have. So, if your discriminant is a positive number, we have 2 real solutions. What that means graphically is that the parabola, that's the shape of a quadratic equation, actually crosses the x-axis in 2 places. Okay. Now, if your discriminant gives you a value of 0, exactly 0, not a positive number, not a negative number, equal to 0, then you have 1 real solution. And what that means graphically is that the vertex of your parabola is on the x-axis. It only touches the x-axis at exactly 1 place. And lastly, if your discriminant is negative, that means you have no real solutions, but that you have 2 complex or imaginary solutions. And what that means is that your parabola never actually touches the x-axis. So let's go ahead and look at a couple examples of what these kinds of questions would ask and how you would do them. It says determine the number and the type of solutions. So we need to say how many solutions we have and what type of solutions they are. And so we have 4x squared minus 2x equals negative 5. Again, we want to get that into standard form. So 4x squared minus 2x plus 5 equals 0. My a value is 4. My b value is negative 2. And my c value is 5. So b squared minus 4ac, plugging into that, negative 2 squared minus 4 times a times c. Negative 2 squared is 4, minus 4 times 4 is 16, times 5 is 80. And so I don't even care what the number is. I know that that's a negative number. That means I have no real solutions. I have 2 complex solutions. Okay. The next example, again, I need to get into standard form. So 3x squared minus x minus 2 equals 0. A is 3, b is negative 1, and c is negative 2. So b, negative 1 squared minus 4 times 3 times negative 2. Well, that's going to be 1, and a negative times a negative will be a positive. 4 times 3 is 12, times 2 is 24, and that's a positive number. So that's going to give me 2 real solutions. Again, it's not telling me what my solutions are. It's not telling me x equals this and x equals this. It's just telling me how many solutions I have and what type of solution they are. This next one, let's go ahead and get it in standard form. X squared minus 6x plus 9 equals 0. A equals 1, b equals negative 6, and c equals 9. So b, negative 6 squared minus 4 times a times c. That's going to give me 36 minus 4 times 9 is 36. That equals 0 exactly, so that means I have 1 real solution. And that brings us to the end of this part of Unit 1. So we'll start off the next part looking at rational equations.